probably get comfortable with it. What I would do, let's just get an Excel document open. All right, how many people feel comfortable with what I'm going over in Excel after I go over it? How many people feel like they better make YouTube videos about this or I'm not turning it in? How many people want like an Excel-based, I'm going to do the project in front of you day to day? How majority rules? All right. At least you know to Google everything. All right, yeah, if you get stuck, Google it, YouTube it.
I'm recording him. So
Michael, you can't do this.
hopefully that helps.
It's all gonna work.
Huh? I'm hoping I have enough memory. It'll probably.
That's really cool. Is it clear?
Yeah.
Thank you. Thank you, Randall. Can you email that?
Huh?
Can you email that?
Yeah, it'll probably be a pretty big file. I'll try to. I can either do that or I can put it on a flash drive and bring it in tomorrow.
Okay.
All right, here's what we'll do. I'll go through the project explaining it as best I can, but you guys have to ask questions, especially if there's something that I just did and didn't explain, that you guys are like, whoa, I had no idea what you did there. All right, so, get this cleaned up a little bit. All right, so now we have our expected returns and our standard deviations. And our correlations. Now, the reason that I'm doing this, that I'm deleting these as opposed to leaving them all out there like this. Missing one. 70%. Okay. Once you get a little bit more advanced with this, and you have more terms, it's really a pain in the ass to say weight 1 squared, weight 2 squared, plus, all those things. What you'll actually do is you'll actually make a matrix. Now, you guys don't have to do this for the project, but you guys could kind of understand how it would work. You would say something like, this, where you would put these here, and you would put these here, and you would have a matrix here, and so you would say equals this times this, and you don't actually have to do this for the project, I'm just giving you this as an example, and then you would just drag this down and you would do this for the same one. You would drag it over and you would have a variance, covariance matrix. Now, don't do this. It's only worthwhile when you have multiple classes. Okay. How do we get started? Let's look at what we are asked. Derive the efficient frontier using equities and bonds. Let's say U.S. large stocks. So that's clear, and I'll just repost this after we're done. U.S. large stocks and U.S. bonds. So we're working with this one here and this one here. When you only have two assets, there's only a small amount of unique proportions that you can have in an efficient frontier. What I mean by that is, if you have 100% in one asset, you have to have 0% in the other asset, you have to have 90%. So you can do this pretty easily, and let's just do it this way, because I don't expect you to use Solver. If you want to use Solver just to get used to it, you can. What I would do is just say This is the weight large stocks. This is the weight of bonds. This is the total weight expected return, standard deviation. You need 5 columns here. These two you can leave blank when you're working with Solver, but as I mentioned, what you can do is you can say 1, and let's just go down in 5% increments. And here, what you'll obviously want to do is you'll want to say equals this other cell. Actually, you want to say equals 1 minus this other cell. So as you do this in 0.5 increments, and then if you grab both of them and go down to 20, maybe that's too many. Maybe we should have only gone down and it'll give us lots of nice points. Okay. This gives us our weights. Now it can only be in these weights. I mean, obviously it could be 27% and 73%, but we're only looking for points. The total weight doesn't even really matter here. We just say equals 1 plus the other. And of course we're going to get 1. Our expected return here, weighted average, so we say the weight times the return. So this is the weight of large stocks times the return on large stocks plus the weight on bonds times the return on bonds. Now, what do I need to do here in order to make certain that I can drag this down? Yep, exactly. So I can go up here and I could put in just the money signs. If you're working with the Windows and you hit F4, it'll lock both of them. If you want to just keep your hands on your computer, you can keep hitting F4 and it'll give you the multiple options. So see what I did there was the first time you hit it, it's going to lock both. The second time that you hit F4, it's going to lock only the number. The third time, it's going to lock only the letter, and it's going to go back to nothing. Now we can see if we're all in stocks, we get the return that we would on stocks. If we're all in bonds, we get the 5.5% return we would on bonds. Now with standard deviation. I'm going to not name these cells yet because I want to name the other cells weight on stock, weight on bonds. So what we're doing here is we want to put in the formula. So we need the square root of weight times weight times, and again, we know that we need to lock these, right? So we have standard deviation. So standard deviation of large stocks, and we need to lock that, times the standard deviation of large stocks, and we need to lock that, plus weight on bonds times weight on bonds times and the last term is, anyone? 2 times weight of stocks times weight of bonds times and the last thing is correlation. So we come down here. Now, the way that I've done this, normally this is in a 5 by 5 matrix and we have ones. So what this would normally look like when you see a correlation matrix is something like this. And then there's a 1 here, and a 1 here, and a 1 here, and a 1 here, and a 1 here, meaning that the assets are correlated with themselves. But we don't really need to do that. We just take off the 1s and make it a little bit smaller. So what you have here is every possible correlation that's not equal to 1. So the correlation between the top, US stocks and bonds is 40%. And we need to lock that. And again, we get the standard deviation we would if we were in all stocks. We get the standard deviation we would if we were in all bonds. And all combinations in between. Now, if we want to graph the efficient frontier, what I recommend doing is using the scatter plot. The scatter plot lets you choose both x and y, and I would just use one of these that has a connected point. Select the data. When you add the series, what you're wanting to do is for the x values, you'll have standard deviation. And for the y values, you'll have expected return. Happy days, we end up with a nice little curve. If you don't end up with a nice little curve, it's not right. Okay? And then I would just call this, you know, two fun, efficient frontier. Now, that's the easy part of the project. Glad I showed it to everybody. For the tough part of the project, we have 3 more weights in here. So, the weight of small stocks, the weight of real estate, and the weight of international. Now, obviously, as I mentioned yesterday, we can't just say what is 100% and then say 0, 0, 0, 0, because as soon as we get here, we can't do this again. We can't say 0.99 and then 0.01. Obviously, I'm just making those up. So we have to figure out a way for Solver to tell us the correct answers here. Just leave all the weights blank. And what I would do is I would just highlight a line, use this as your working line. So in total weight, you can call this the sum of the other 5 weights. The expected return equals, here, the weight times the return plus weight of bonds times the return on bonds plus, you guys get the idea. Leave this blank also. Now, for the fun part, and this is where I'm going to come back in and I'm going to name these. Remember, naming them yesterday helps because you can just write out the thing faster. So we're going to call this WL for weight of large, enter, WB for weight of bonds, WS for weight of small, WS, WB, let's call this WR, and WI. I would go back up here, I would do the same thing. So instead of calling this C3, and you're going to have to hit enter every time, and if you don't hit enter, it's not going to change it, but we'll call this standard deviation of large, or SL.